Welcome to this second part of the session on LULC mapping using QGIS. In the first part, we had installed semi-automatic classification plugin in QGIS. We had used the plugin for downloading Sentinel-2 multispectral imagery, 9 bands of the Sentinel-2 multispectral imagery for Pune region for recent imagery, which is free of cloud cover. And then we pre-processed the imagery to convert the values of digital numbers of each pixel to reflectance values, and then we have clipped all the 9 bands to the area of our interest, and then we had created a training input file with .scp extension. And now in this session we will start creating regions of interest or training sites for various macro classes and classes, and then we will use those training input training sites or the regions of interest for land use land cover classification for the whole image, for the whole extent of Pune city region. Training sites or regions of interest can be created using manually. It can be created using this polygon drawing tool, which is available in the tool bar of SCP, the create a ROA polygon. Such polygons can be created where the land use land cover is uniform, or where the land cover, the class has extensive area and it is spectrally homogeneous. For example, a water reservoir, you can easily create polygon over there. For otherwise, extensive forest area, extensive for or extensive bare land, where you can easily create such open land, where you can easily create such training sites or ROIs. In case of urban setting, where there are all kinds of land use land covers next to each other, built up area, open parks, and then roadways and bare soil, everything is close to each other, then you can make use of this region growing algorithm, which is known by the name of activate ROI pointer, which can be used to create a seed pixel. And you can specify the spectral distance here, the threshold, so that given the spectral similarity, it will around this seed pixel, it will take all the pixels within the spectral distance or given spectral distance, and it will create a ROI or a training input. So that will be useful for creating the training input for urban built up area and in the urban setting for any class. So we will make use of both of these tools which are available here to create number of training sites for different classes. And we will also have macro classes concept also. So macro classes are composed of several materials having different spectral signature. For example, water can be a macro class, can be defined as a macro class, under which there are several classes of water having different spectral signatures. For example, deep reservoirs will have, or lakes will have a kind of spectral signature, and then canals will have a different kind of spectral signature. Shallow ponds will have a different kinds of spectral signature, and rivers will be having a different kinds of spectral signature. Similarly, you take in macro class of vegetation, there can be a forest strand which will have a different spectral signature, and cropland will be having different. In the urban area, parks, grasslands, they can also be categorized under the macro class of vegetation. So in this way, what we will do, we will create both the macro classes and subclasses, and then we will make a decision on whether to go do the land use land cover classification using the macro classes, broad classes, where there it will be an easy classification, where there will be the broad macro classes of vegetation, water, bare soil, and our built up area. Or if you want to have a very good LULC map, with the different spectral signatures with many multiple classes, but for that you have to make an effort of creating very good training sites for each class. So there are certain guidelines which you need to follow for creating those such training sites or ROIs. The guidelines, by the guidelines we mean there must be as many training sites per each LULC class as possible to capture the spectral variability. As for example, to capture the spectral variability of water, there has to be many ROIs, and these ROIs should be spread all over the image instead of being concentrated in a particular pocket of the image. And there should be at least 5 to 10 training sites or ROIs per each class. If you follow such guidelines, you can have very good training sites prepared, which can be used as an input for doing the supervised classification. We will see how to do it, and we will make we will make use of different band combinations, making use of these 9 bands of Sentinel-2 imagery which we had downloaded for this region. We will do different combinations of these 3 bands, true color and false color composites, because in there are certain band combinations where it will be possible to identify or distinguish a particular feature from other. Yeah, so we in that way we can generate training input, making it through the such band combinations. We will also take help of NDVI value for identification of the feature and generating the training sites. In all these polygons that you generate as a training input, training site or the ROIs, they are temporary polygons unless you are saving it ultimately. And once you save the training input, then they will be saved. The spectral signature will be calculated, and they will be listed in the ROI signature list. This is here they will be listed. Uh, and you can merge many of those classes, and you can delete the classes, you can calculate average signature, etc. Now let us start creating ROIs. So before going for creation of ROIs, you can go to this ROI options tab, and here you can check this display NDVI, a vegetation index value with the cursor, which will help in identification of the pixel, what kind of land cover is there, that you can have some idea through the display of NDVI, that we will check it. Then we have these bands. Now first of all, these we have to create a band set. Previously the band set was created using converted images. Now you have to create the band set using these clipped images. You go to SCP plugin main menu and click on band set, and then you clear whatever band set is there earlier. You can add the bands which are loaded in QGIS, which are these clipped images. Then you can click this button for selecting all the images, and now they are, as you can see, there are 9 bands: B2, B3, B4, B5, B6, B7, B8. B8A is missing somehow, B11 and B12. And so a new band set is created, which is the default active band set, and you can check the wavelength, the settings of the band quick settings. Select the Sentinel-2, and then wavelength, you select the micrometer unit and select the date from which the imagery was collected or downloaded, that is 18th February 2024. That if you select it here, it will be displayed here. So let me select 18th 2024 February 18. The date is not changing here. Let me redo that. uh, Let me put off this option for the time being. I will go to the SCP. I will select the band set, and now you have the all the layers which are listed in the QGIS panel. Then you can select the wavelength, micrometers, and then you select the date, which is 18th February 2024. So yes, now the band set has been defined. Now we will note down the sequence where these bands are listed in the band set. Starting from the blue band, B2 is at the position 1, then green band at position 2, red band at 3, and 5 and 6 are vegetation edge bands, then 5, 6, 7, then 8, which is an important region and near infrared band at position 7, and sphere 1 and sphere 2 at 8 and 9. So if you want to generate a cloud cover a true color composite with red band, green band and blue band in red, green and blue channels, then your RGB combination would be 3 2 1. Your RGB combination in that case would be 3 2 1. So here this RGB in this toolbar, you can generate virtual layers by giving the different band combinations. So if you type 3-2-1 and if you press enter, it should be generating a virtual layer. uh, First of all, let me save this project. The window has been inactive for a long time, so it is not reacting. Let me save it. Save as in the day 4. I will save it as LULC classification under solution. Then I will again define the band set is okay. Yeah, it is now generated. You bring it to the virtual band set, the temporary band layer that has been created. With the 3 2 1, you have this true color composite. The gray portions are the Pune city urban areas, and this is Kadakwasla Lake, the Panchet and Warasgaon lakes, and you have the river, Mota river, and this is the confluence point of Mota and Mula. And in the downstream region, you have the command of Kadakwasla project, and these are the bare hills. And in the western side, you have the forested areas, and also reservoirs. So this is the true color composite, the way our eyes will visualize when you are at that particular height in a cloud free day. Now this image will not be of much use to you, even though it is possible to create a polygon training input by manually drawing the training input for water. But still, let us try and visualize the false color composite. uh, for false color composite, if you check the band set again, the NIR band is at 7, red band is at 3, and blue band sorry green band is at 2. So it is 7 3 2, and you know that very well that in this band vegetation will be appearing very bright in red tone. Healthy vegetation will appear very bright, or forest will appear very bright red tone. And then in the downstream of the city there are agricultural fields. You can zoom in and you see the even the shape of the fields also on either side of the river and in the canal serving area. And also you can see that water has very low reflectance in NIR band, and that's why you have the water bodies appearing very dark in this color composite. So what I will do is I will try to create a training input for water from this scene using this create a ROI polygon. So you can start with your mouse, you keep clicking the polygon, take care not to include any uh, land portion inside it, and then when you are complete you can just right click. So you have this polygon of water. Similarly, I will create more polygons by pressing the control button for the same class of water macro class and reservoir class. I will create this polygon, but maybe I had included small island inside it. So you should take care of such aspects because your spectral signature will be modified if you include any other average spectral signature will be modified. So here it is pretty clear, there is nothing. So you can start, but you should be pressing control button. Zoom to layer, press control button, and then zoom into the lake. And then create another polygon. You can also try creating polygon in the tail end portion, where while taking care that land portion is not included, none of the pixel from the land will be included. Similarly, you can do it for these reservoirs. So once you create so many polygons in the water bodies, um, you can click on this button, save temporary ROIs. These are all our temporary region of interest or training sites to the training input. You can press this. Then what will happen is the SCP plugin will start calculating the spectral signature, average spectral signature of all these polygons, and then it will be added to the ROI and signature list. uh, so here I have given the macro class name of water and class name of reservoir with both the class ID, macro class ID 1 and class ID of 1. I will change the colors here. I will take the deep blue and light blue. Now in this way I had created one training ROI. Similarly, I can in fact you can create multiple ROIs and you can merge them using the options which are available here. You can merge highlighted spectral signatures and then you can calculate signatures for highlighted items. Like for example, if you highlight this, if you want to calculate signature for this highlighted item, you can click on this button. Let us check. Yeah, it is it has calculated and it has been stored in the ROI and signature list as a type R and S. R and S means ROI has been created and signature has been calculated. You can delete any of the ROI class training input using this button, and then there are other options like this option is for adding highlighted signatures to spectral signature plot. Yeah, now we can let us add it to spectral signature plot. There is only one signature, and you can see how the water has a spectral signature varies along the wavelength. Now it will have the local maxima around blue band, and then in the R band it has a low reflectance. In the NIR band it has very low reflectance, almost zero. So this is one typical spectral signature curve of water. Now let us create under the same macro class of water another class of shallow reservoirs, or let us do it for rivers. So we can create small polygons over here by zooming, or what you can do is you can make use of this region growing algorithm, or activate ROI pointer. You can click on the seed pixel and then select a threshold value. The default threshold value here is 0.002. So check whether it is only water pixels are being selected, otherwise you can decrease the threshold, say 0.001, and then you refresh it, redo the ROI at the same point. Or you click on a new point. Yeah, this seems to be more reasonable. So I can select this as an ROI. Let me select more ROIs along the river by pressing the control button with the same threshold. So you have two ROIs, training sites for a river. Now this is a different category of water body. We can keep it under ponds. Now let us see this river at the confluence point. I will select. Now keep in mind that your ROIs should be spread all over the image. Let me click here. Yeah. But is it being added to the polygon list, or it is being recreated afresh? It is being added. So you can add it and then we can merge the training signatures. So I can keep the MCID as 1 and CID as 2. I will name it as a river and then click on this save temporary ROI for training input. So let us have more polygons from different points. So at this point you have selected. Let us also select near the border. So we have these two, and you keep the pressing the button. You can select here the confluence point of Mula and Muta. And even select towards the northwest. So you can add it again by clicking on save temperature ROI. Now again you keep your MID and CID as 1 and 2. River, I have to change the name, so add it. What I can do is I can merge both these signatures by using this option of merge highlighted spectral signatures into MCID 3 and CID 1. You can click OK for now. So once it is merged, you can delete the old ones using delete highlighted, and then you can change the CID to 2 and name of class is river. Now let us go for ponds, shallow ponds. Within the city there are many water bodies. Again we will go for region growing algorithm. You click on activate this and zoom, click somewhere inside number 1, and here why is it disappearing? 1, control 2. If you are doubtful about it, you make sure to click in the right location. You can even have this. So they are located somewhat close to each other, so you should try to have more. Where are they located? Yeah. So let us pick some water body here, shallow body, which is in a different tone. Check here. So we have covered the northeastern part. I think every time you have to lift your finger from control, otherwise it is not adding them. So now I can, I have forgotten to give the proper MC name and number. So it is MC name is 1 and the code is 1 and number is 3, and then the it should, we can name it as ponds. You can have few more ponds from different portion of the uh, images, and then we will merge them. So I have got one. Two. From this point, no, this cannot be. So how to remove this? Let it, I think I will start it again. Let me. merge these two. Then I will delete them and rename the code CID as 3. Now let us use a different band combination. Now I want to delineate vegetation areas also. I will do it using this combination only. So let me go to brighter red areas where I will use the you can even go to the ROI options and display the NDVI so as to get a better idea. So NDVI is here pretty high, 0.6 and 0.7. I can make a polygon here, manually draw the polygon where I have high NDVI. Yeah. Have to draw the polygon. Yeah, it is done. So this is forest. Let us look for other regions. Yeah, here it is pretty high, 8.82. These are dense vegetation areas. So again press Ctrl, click on this polygon. I hope I have created the polygon. Yeah, it is getting generated. So this requires due diligence and application of mind at the time of creation of training input. So for the purpose of demonstration, I think I should not spend lot of time in this. So again here I can have another polygon. Whether it was created or not, yeah, it is getting. Then you can give the macro ID of 2 and class ID of 4, macro class name as vegetation, and class name as forest, and you calculate the signature. So you can check your training layers which have been created, which are in the form of dark polygons. You can check here these two. These are yeah, these are one is forest and another is water. So you had created it for forest. You can have more of it, and then you can merge them. Now let me go to the another band combination. The band combination which is useful for identification of agricultural areas or fields is sphere 1 in red channel, NIR in green channel, blue in blue channel. So that will be if you check the band set, sphere 1 is 8, or is it sphere 2? Yeah, sphere 2 NIR and blue 971. Then you can select 971 here. 9-7-1 and then press enter. Then it will change the virtual layer. The combination is changed. Now here you can see you can identify the agricultural fields in the downstream of Pune. So you can make use of this region growing algorithm to identify the agricultural lands. You press on this activate ROI pointer and go to any field. Here you have the NDVI values also pretty high. So here you have one polygon. You can have more by pressing. You are still having that 0.001 as the threshold. You can change it as per requirement. Yeah. So with these polygons, I will create a new class. Uh, it should have been uh, crops instead of forest. You can select the crops from different part of the imagery. You can see that downstream of this small dam there is agricultural land. Here also you can choose this. And it need not be that you have to be confined yourself to this virtual raster. You can also add your base map, quick map services, Google satellite image, which will be of higher resolution, but it may not be from the same period of time, but you can at least get some information also from the base map. And also you remove all these clipped layers which are already included in the band set, which are not required from the layers panel. So you have the training layer, SCP training layer, temporary layer, virtual band set, and Google satellite. Now let us check in the Google satellite. Yeah, you can see some of the croplands you can see here. So these are croplands. The one which the standing crop has high NDVI about 0.4 to 0.6, and the one with bare soil have less, 0.4 or so. if it is slowing down your system, then you can just deactivate it. Let us go back to our agricultural fields, the command downstream of dams. I have intentionally selected one some region which has spectral homogeneity. What could be this region? I can make use of my Google satellite. It it is not proper to select this as a polygon. Now there are other band combinations that I was talking of. Now let us we have identified the crops, but I wanted to have more inputs of crops. Then let us turn our attention to built up area. So in this combination of sphere 2, NIR and blue, you can also see the built up area in gray. You can zoom in and then you can select the region growing algorithm and click somewhere here. Press Ctrl and keep collecting your samples, training sites from this portion, and then we will move to some other portion. So you can check the base layer also, because it may not have changed the built up area high result because we have a high resolution imagery. But there is this network request, some issue is there. Yeah, so this is built up area definitely. So what I will do is I will immediately create another signature. I will keep it the macro class of 3 and class ID as 6. I will call it as built up area and class name as buildings, and then I generate my signature and add it to the training input. Yeah, so here we can have more built up area that you can this cluster. stick to this cluster only. Yeah, so I will add it as another built up and buildings with the same class and ID. I will add it, and then I will afterwards I will merge them. Now here if you see in the virtual band raster, its resolution is less. Otherwise you can see there is distinguished feature between. Here it appears in different tones. Maybe here you can separate the bare land portion from urban built up area portion, which will be useful for our spectral classification. And also we have one combination. I will keep it as it is. We have one combination of swir band, red band, and green band. That is swir 2 band, B12, and red band, that is B4, and green band, that is B3. B12, B4, B3, you check it in the band set. This combination of SWIR 2 red and green band helps in identification of urban areas and bare soil separately. Urban areas will be appearing gray, whereas bare soils will be appearing in light green in color. Let me turn off this NDVI display if it is distracting. Where is my band set? That's I wanted to look at my band set. Yeah, so we are talking of B12, that is 9, and red and green, B4 and B3. 9, 3, 2. Let us implement it. The combination of 9, 3, 2, where urban area will be in gray and bare soil will be in light green. Now let me load. Yeah, so you can check the locations of bare soil and urban. Vegetation should be in brown color. It doesn't matter because here you can distinguish between this is bare soil or shrubs and this is the urban area. So you can have a different class if you can select your region growing algorithm somewhere here. So this you can mark it as bare soil. So go to training input, give 4 macro class and 7 micro class. It is bare soil, and then I will name it as wasteland, or you can keep it bare soil and bare soil. And then you generate your signature and add it as a training input. Now at least we have now four macro classes and different micro classes. You will have more micro classes and then we will generate. I should not aim for doing some research project here. The intention was to make you aware of how you can generate a very good LULC map. Now let me select few land classes that we haven't collected till now, like this. This is a roadway, I guess, or is it a railway track? I want to have the roadway, the arterial roadway, because it is in the main city. You will have so many of them. So what I can do is, yeah, this is the road. So let me have my virtual raster. Uh, it is not much distinguishable, but still you can select the pixel and see. It is really selecting the road. Maybe I will decrease it further, 0.0005. The spectral distance. Let me but these are small roads actually. Let us go to main. Yeah, this appears to be a big junction, and here I can try to have the road. What else has been selected? Uh, bare land was also coming in, so you can select somewhere which restricts that portion. This intersection. Yeah, so this intersection, this pretty much covers the roadways. So what I can do is I will create a new, it will come under built up area macro class 3, and I can give a new CID 8 under built up, and then uh, C name is roads. So it gets calculated. Now let us check for more. Yeah, this is a very good training site. Basically it is covering the paved areas, but also some other bare soil also, but I can add it as built up, and roads 3 and 8. I will I will add another signature, and then I will merge these two, this one and this one. I will merge using this option, merge highlighted signatures into 9 and 3. Fine. I will delete the old ones, and I will change the value of 3. I will make it 7, and here I will make it 8. Buildings also I will merge 3 6 and 3 6. I'll merge the signatures, and then I will delete them, and it cannot be wrote further. I made some mistake with the buildings, so what I will do is I will delete this. I will create it again, buildings. This I can add up to built up and roads 3 and 9, and 3 and 9, 3 and 9 I will combine to 10 and 3, and I will delete these two, and I will make it 3 and 9 again. Built up and buildings I have to collect. So let us have a look at extensive built up area or buildings. The high resolution satellite imagery, yes, this chunk, yes, this can be built up and buildings. So it is 1 2 3 4 5, it can be 3 and 6. Generate it. So it is 3 and 6 buildings. You can have more of the sites of buildings from different localities. Say this one, press, you can check them. It is actually built up area. Yeah, in fact you can have more of them by pressing Control. Yeah, and now you can generate signature 3 and 6 for buildings. You can merge them 3 and 6. So I had these from here and from the main city, and let me also have it from here. This appears to be solar power plant. Let me select some urban locality. Yeah, so let me select from this portion built up area. You can even have roads, adjacent roads. Let me select the region growing algorithm here. Yes, it is more or less built up area. So it is 3 built up and 6 buildings. Add it, and next to this area we have the pavement roads. Yes, that is good. We can even select here. I can add it both of them together, 3 for built up and 9 for roads. And then add. I will merge these two, roads and roads. 3 and 10. Then I will remove these and make it 3 and 9. I will merge these buildings 3, 6. Three ten. Okay. So 310 is buildings. Remove them. 310. So I may make it 6 and I'll make it buildings. So we have a collected enough signature for built up area. Vegetation and crops, I have to select few more, and bare land I can have. So you can also select vegetation from inside the city. So let me again go to our virtual band, NIR red green, that will be 732. So under 732, virtual layer. So this area is more greenery. I can select this portion and I can add it as vegetation number 2, and this is not forest, this is urban forest or urban trees. I can make a new category of vegetation and trees. So that is 2 and 7. We can change these class IDs afterwards. This portion also I will make it as 2 and 7, vegetation and trees, add, and then I will merge these two as 2 and 8. I will delete these two and I will make it 7, 2 and 7. So only I have to select few more classes of bare bare soil. NIR Sphere 1 red band, that combination will be useful for NIR Sphere 1 and red, that NIR Sphere 1 and blue, that will be useful for healthy vegetation. Now I will go back to agriculture. Sphere 1 NIR and blue, Sphere 1 B11, that is 8, NIR, that is 7, 8, 7, and blue 8, 7, 1. Which will be helpful for identification of agricultural lands that I had identified here earlier. I will go here and I will also select few more signatures or ROIs. Press Ctrl and select few more. And then I will add it to 2 vegetation and 5 crops. So I will merge this 2, 5, 2, 5 into 2, 6. And I will delete them afterwards. And I will make it 5. So this appear to be a bare soil. This class is not yet represented. So you can create region growing algorithm by increasing the spectral distance. Yeah, you can even select more of it. You can add it as 4 and 8, which is bare soil and bare soil. Calculate the signature, and then I will merge these two, 4, 9. It has become I will delete these two. One more class I will have from the Western Ghats region, where there may be some rocky outcrops which are not vegetated areas or shrubs. Yeah, this is a rocky outcrop. You can select it as bare soil and rocky. So you can have the region growing algorithm here. You can see this entire region is rocky outcrop. So you can have a new class of 4 bare soil and 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 rocky outcrop. You can generate it. So you have one. I think that is pretty good level of generation of training inputs. We can go on and create more and more training sites, but the purpose is now to make you aware. So now we will only change the numbers of the classes, or if it is distinct you can continue. There are 10 classes, 1 2 3 4 5 6 7 8 9 10. 10 classes and 4 macro classes. So once you are finished with your creation of ROIs, we will next create a classification preview. Before generating the classification preview, you can just have a look at these colors. You can slightly make changes. Vegetation should be green and forest, trees, cropland I will take it as pink, and then built up. Customarily built up is represented in red, and then roads I will go for gray, buildings I will go for orange, then bare soil yellow is fine. uh, Again under bare soil another kind of yellow, another then rocky outcrop. You can go for brown maybe. So you have this color combination, and now let us generate classification preview before final classification. This changing of region of interest, and then it is an iterative process. If you have more ground information, you can create more better training sites or the ROIs spread over entire images, and each class having a high representation of at least 5 to 10 ROIs. You check the band set, active band set, if it is still the same. I think it is the same. So here the input band set has to be 1. Now you go for band, under band processing you go for classification. Before that you can see the preview, activate classification preview pointer, this one. and then you can give the set preview transparency to 50% so that you can see what is on the base, and set the preview size 500 pixels. Now you go to processing, SCP, band processing and classification. You select the input band set as 1. There is only one input band set, and use class ID for training, and then use the maximum likelihood algorithm. Other options are maximum, minimum distance, multi-layer perception, random forest, spectral angle mapping. Now we are going not into those details. We will go for maximum likelihood, which is mostly used. You activate this classification preview, and then you click anywhere. But this is outside. I think it is outside, so it is somewhere here. So let me zoom near Kadakwasla Dam. Let me click here. So it will generate a classification preview of 500 pixels as selected. And if you are convinced about the classification preview, you can generate the classification preview at some other location, and then you can finally generate your land use land cover map, making use of class ID. There are 10 class IDs that you have generated. So it will take some time. Let it calculate. Let it generate. So it has generated classification preview. Uh, so it is the lake and bare soil and some buildings have also been represented. Let us check at some other location. You can check the classification preview here. The roads are being represented pretty well. Uh, the greenery along the canal has been represented as a cropland. Let me click somewhere here. So you can see, is this the rivers? They have also come out to be pretty well. The roadways have come out to be well. These are the rocky outcrops. I don't know what it is. We have to check on the field. But the built up area is also, buildings is also prominent in the city, as can be expected. The tree portions, these are the trees. You can see, you can check the high resolution base layer. uh, so trees are represented well. This class, the roadways are represented well. Even the bridges are represented well. These are the roadways. The river has come out to be fine. Then but there is some misclassification, as this is the region where there is lot of buildings, but it has misclassified not just buildings but also even the large portion it is showing as roads. So some confusion between built up area and roads that can be expected, because both have similar spectral characteristics. And if we go to the downstream of Pune and you again do the classification preview, it should have more of a cropland as expected. So all these are fields which are cropland, as you have depicted by uh, pink color. These are all the croplands, river, and along the river there is vegetation, which is either in the form of trees, or sometimes where the thick vegetation is there, it is being shown as forest. And and in between there are some built up areas. Here you have the built up area and some bare soil. It has been misclassified as rocky outcrop. Maybe I should have given more training inputs for rocky outcrop. So let me go to the region where you have the actual rocky outcrops. Now here, if I generate it, if I generate the classification preview here, let us see. So this is your water body. Somehow in the water body you got another class, which is maybe it is a shade of blue, I don't know. So here you have yeah, the thick forests, as you can see. These are represented as forest, rightly classified. And then the bare soil here, it is classified in yellow. But the only issue is with the rocky outcrop, which has come out to be very prominent, which should not have been. So I have to give more training input of rocky outcrop. So this is a fairly good classification that we have generated by spending about 1 hour time. And in case if you generate very good training inputs with lot of more ground information, and diligently if you pick up the training input from all over the images, you can definitely create a very good output LULC map. Now here also you can see the roadways have come out to be very good, and then the bare soil, it is in yellow, and then some part is showing as rocky outcrop. The buildings, everywhere the buildings are there, and they are represented in orange. That is built up area is high. In there are some areas like maybe their parks are empty. These are actually fields. They are represented in pink. This is a big area which is bare soil. It is represented in yellow. So you can just verify, you can do the assessment. I think it is reasonably good. So we will try to generate for the whole area. For generating for the whole area, you can go to semi-automatic classification plugin, band processing, go to classification, and again you check the input band set 1. Then you can select the class ID, maximum likelihood, and then you can run. It will ask you to save where you want to save. Then in the solution you can save it as Pune supervised classification. This we are doing it by class ID. We will also do it by macro class ID. Then we'll also see how it looks like. So if you run this, it will generate the whole LULC map for the whole extent of Pune. It will take some time. So let it generate. I have created LULC map for whole Pune region using macro classes of water, vegetation, built up, and bare soil, which looks something like this. And then I had also created LULC map for the whole region using those 10 classes for which we had prepared training inputs. Uh, the classification is reasonably has come out to be good. However, there is some misclassification between the macro classes of water and built up, which you can have a look into. Otherwise, you can see the central area of Pune has a lot of built up area as expected, and then the pockets of greenery you can check where they are and compare it with the base map. And in the outer side you can see away from the city the bare soil, wherever there is bare soil, it is marked as yellow. And in the downstream of the city, in the command area on either side of the river, the agricultural fields have also been marked or mapped pretty well. This is uh, this has come out to be a reasonably good product. And then the macro supervised classification, we have already seen these classes of arterial roads, rivers, agricultural crops, and then built up area. It has come out to be good. Only thing is, in because we had only one training input for bare rocky outcrop, it has misclassified at many locations. There is a misclassification between rocky outcrop and bare soil. You can improve upon it by defining more training classes, training inputs or ROIs. This is a iterative procedure that you have to adopt for improving, and there are inbuilt tools in this plugin for checking the spectral signature by plotting the spectral signature of overlapping classes and calculating the spectral distance, and whether if the spectral distance is as per accepted statistical measures of spectral distance, whether they are it is the classes have acceptable levels of spectral distance, that such assessment can be done. And then the LULC map can be improved upon in the next round. So you can have a look at this plugin. The idea of this session is to make you aware of uh, the procedure to be adopted for creating an LULC map using high resolution Sentinel-2 imagery. That too latest imagery. You can have near real time, very you can create land use land cover maps within a year. For representative LULC maps can be created for various applications. In the earlier version of this SCP plugin, that is 7.x, which has been updated to 8.x in January this year only, there was provision for unsupervised classification also. In there are two methodologies, ISO data and k-means. There you used to mention the number of classes, and then through clustering, spectrally similar pixels are clustered, and and then for those unassigned classes you have to assign the some land use class. Now if you combine unsupervised classification with supervised classification, unsupervised classification followed by supervised classification, you can improve the overall quality of your LULC map. So you can explore this plugin documentation and the examples which are there in the website. It is entirely driven by individual effort, which is appreciable. And the latest version will also be expected to have the unsupervised classification provision. Then you can explore on your own. That's all from my side for this session on LULC mapping using QGIS. We will be having two sessions tomorrow on QGIS, Python scripting in QGIS, and customization, QGIS customization using Python. So let us meet tomorrow. Thank you very much.